Alright guys, so this unit, just to remind you that we started on Tuesday, is conics. Conics, there's four types: parabolas, circles, ellipses, and hyperbolas. Tuesday we talked about parabolas. Today we're talking about circles and ellipses. We're probably going to spill this lesson over into tomorrow a little bit because our lesson on hyperbolas is super short. So with circles and ellipses, we got a little bit more to talk about. But basically, we're just going to be learning how to graph them, what their equations look like. That's about it. So, bless you. Let's go ahead and jump in here. I've printed this slide for you, so you can just find it on there. What is the equation of a circle? So we all know what a circle is, but this is what the equation of a circle looks like. I'm not going to go into how they got this in extreme detail, but it has something to do with the distance formula, if you guys remember that from Algebra 1. But anyway, it can look like this on the top or like this on the bottom here. The H and the K represent the center. Okay? The number that's over here, if you take the square root of it, that will tell you the radius of your circle. Now this can be written in the fashion that it is down here in the bottom. If you were to divide everything by r squared, so if you divide r squared by r squared, what do you get? 1. And if you divide each of these chunks by r squared, you get that. So it's another way to write it. I'm just kind of letting you guys know they can come in two different shapes or representations. So let's get down to graphing. So go ahead and write down this slide, please. Okay. So the number that is inside the parentheses with the x, you're going to change its sign. And it's an x value. So we're going to put a positive 2 for the x value. And same thing over here. The number that's in the parentheses with the y, we're going to change its sign, and it is a y value. And those two things together tell us what the center of the circle is. My radius can be found by taking this number over here and square rooting it. So my radius is 3. The reason being because this is actually r squared, right? So if I want just r, I would have to take the square root of it.
You're making them both for the center, they're both opposites.
Yep. On this one, they're both opposites. And then we can graph. So I'm going to plot a dot where the center is. It's at 2, 3. So I'm going to go over 2 and down 3. And my radius is 3. So I'm going to use that to find 4 other dots. And once I have those 4 dots, I'm going to connect them to draw my circle. So how I'm going to use my radius is, since I know it's 3, I'm going to go up 3 spaces from this dot. So let's do that. 1, 2, 3. That puts me right on the x-axis. And I'm also going to go down 3 and put another dot. I'm also going to go 3 to the right from my center and 3 to the left. 1, 2, 3. So I'm going to take that radius length, which is 3, and I'm going to go up, down, left, and right that far from the center. And once you have 4 dots, I'd say you have enough information to sketch a pretty decent looking circle. And that is the circle that comes from that equation there. Yeah. What about the radius? Okay, so back here, maybe. The number over here is r squared, right? So that's the radius to the second power. So if this is r squared, and I want to know what my radius is, I would have to take the square root. So my radius is 3. And then from there, what you're going to do is, you guys know what a radius is, right? It's the distance from the center to the side of your circle. So I would just go up 3, down 3, right 3, and left 3. And going up, down, left, and right works really well because when you're on a coordinate axes, those are easy dots to find. All these other ones would be at weird decimal values, and you can't really find them. All right. So let's go ahead and have you guys try one of these. You guys graph that one. Andrew, what is the center of this circle?
I don't really know the x value, but I know the y value.
That's right. And you don't know the x value maybe because it's not there. And what that means is that it's going to be 0. Cassandra, is she here? Cassandra? Radius 2. Is it Cassandra or Cassandra? Oh, okay. Like whenever you go to like a cocktail party, it's Cassandra, isn't it? Right? All right. My name is Cassandra. All right. Let's go ahead and graph it. So 0, 4 is up here. 2, 3, 4. And then radius is 2. So I'm going to go up 2, down 2, right 2, and left 2. He's waving, bro. Okay. It's time to go on to the next problem. All right. Ellipses. Ellipses. Notice that they look almost exactly like one of the versions of the circle equation I gave you, right? The one where it was 1 on the side. But notice that the denominators are different, okay? So now look at the shape. The shape looks like a circle and it's been stretched. So the reason for that is you can kind of think of it like this. You know how like in a circle the radius is the same all the way around? Well, on an ellipse, it looks like you can kind of think about it like this. I don't think this is like totally correct, but it's true and it will help you get the right answer. Is that this is kind of like the x radius, and this gives you kind of like the y radius. So, in other words, if you took this and you took the square root of a squared, what would you get? You'd get a. And that tells you the radius for the x value, how far to the right and left you go. Okay? Whereas this number here, if you took the square root of that, you get b, and that tells you how far to go up and down, kind of like your y radius. Now, they're not really called radiuses. They're called major axis for the long one and minor axis for the short one. So we can label those really quick. The long ones are called the major axes. And the shorter ones are called the minor axes. And they can be stretched either way. It really just depends on, you know, if the number underneath the x is bigger than the number underneath of the y, then it's going to be stretched horizontally. If the number underneath the y is greater than the number underneath of the x, then the y is going to be stretched more. So that's about it. So other than that, they're pretty much the same as circles as far as graphing goes anyway. So let's go ahead and write down example 2 here. So just like the circle, we're going to start by identifying our center here. So the number with the x is the x value of the center with an opposite sign, right? And the number with the y, which in this case isn't present, so that's a 0, is the y value of the center. If I take this number, the 9, and I square root it, that's going to give me 3. And that number is going to tell me how far to go to the what and what? Because it's underneath of the x value, right? So the number that's underneath of the x value tells you how far to go left and right after you take the square root of it. Okay? And the number that's underneath of the y value, if you take the square root of that, that number will tell you how far to go up and down from the center. Not always. So here's how you know which one's left and right. The one that's under the x value is left and right. You know how like the x-axis is left and right? That's how you kind of remember it. All right. So we're ready to graph. My center is 2, 0. So let's go over 2 and put a dot at 2, 0. And now I'm going to go left and right 3 spaces, right? So 1, 2, 3, and 1, 2, 3. And then I'm going to go up and down 7 spaces. And then we're going to do our best to connect these dots with a nice oval-like shape known as an ellipse. It's not going to be perfect, but there it is. You try. Vivian, what is the center of this ellipse?
The x is 0. I mean, the x is 1 and the y.
Good. And then I'm going to ask Cassidy, what is the left and right radius, if you will? It's 1, right? Because this is over 1, so we take the square root of that, which is 1, and that tells us how far to go left and right because it's underneath of the x. All right, Vanessa, what is the up and down axis value going to be? It is 2. We're going to take the 4, we're going to square root it, and that tells us how far to go up and down. And then from there, we're ready to graph. So we have 1, 0 would be like right about here. And then I'm going to go left and right 1, up and down 2. And there you go.
Oh, dang it. Wait, never mind. No, because my ones are just brighter. And it's supposed to be a circle.
They're ellipses. All right. Would you guys go ahead and copy down this slide, please? Or a circle or a parabola. So we want to be able to tell like what that is. So how can you tell when you're looking at the equation of a parabola? Well, only one variable is being squared. Only one variable is being squared. So for instance, you don't need to write the equation I'm about ready to write, but yesterday we saw equations that maybe looked like this, for instance. X equals 2x minus 1 squared plus 5. Only the x is being squared in this problem, right? I'm sorry. I meant to make this a y. Sorry. Only the y is being squared in this problem, right? The x is not. So that's a parabola when you have that, and only one variable is being squared. Whereas when we're talking about circles and ellipses, all the equations that we've been working with today, both of them are being squared. So for both circles and ellipses, both variables are being squared. Okay, now how can you tell though the difference between circles and ellipses? With a circle, the denominators are the same. And with ellipses, the denominators are different. All right, so I printed this for you, so you don't need to copy that. But I've got 4 different equations here. What they are may not seem obvious to you yet, but hopefully after a few problems you'll see why they work the way they do. But these are actually circles also. Actually what they are is they're half circles. And I'm going to show you how that works in a minute and why. But for now what I want you guys to focus on is what half of the circle are they? There's 4 halves of a circle. There's the top half, there's the bottom half, right? Or there's the left half and there's the right half. Okay. Don't talk about diagonal halves. We're not going there. So, when you have x equals equations, that's about left and right. Okay. So when you have x equals equations, that's about left and right. Now, when it's a positive square root, then that is the right half of a circle. When you have a negative x equals, then that is a left half of a circle. And this applies to ellipses too, by the way. But I'm just going to talk about circles. No, x is left and right. When it's x equals, you have a left and right circle. When it's positive, it's on the right. When it's negative, it's on the left. Over here, when you have a y equals, that's when you're talking about the top versus the bottom, okay? When it's a positive, then we're talking about the top half of a circle, and when it's negative, we're talking about the bottom half of the circle.
Can you say that one more time? No.
When it's y equals, that's talking about up and down, right? Isn't y the up and down variable?
Yeah.
So we're talking about above and below. So it's a top half and a bottom half. The one that's positive is above, the one that's negative is below. All right. So let's go ahead and see what's up with this. I believe I printed this for you. So just go ahead and find example 3, but you're going to need a little space on a separate place that you'll label example 3 to show the work for it. We're going to do 3 things with this equation here. Now, first of all, let me ask you, why is this not a parabola that I'm looking at? Because they're both being squared. Why is it not an ellipse? They both have a denominator of 1, right? So this is a circle we're looking at. Okay? So graph it. We're going to graph that circle first, and then we're going to solve for y. That's a new thing. We're going to get the y variable by itself. After that, you'll see what I mean by this, but we will have therefore broken our circle up into 2 halves, and each half will get a certain equation that goes with it. Okay? So that's what we're doing. So we have x minus 4 squared plus y squared equals 1. I'm going to transition over here. X minus 4 squared plus, was it y equals 1? Okay, so my center is 4, 0, right? My radius is, what is it? 1. Remember, this is not an ellipse. It's a circle, so the number over here tells you your radius if you take the square root of it. All right, so let's go ahead and graph this really quick. We have over 4 at 0. And we're going to go up 1, down 1, left 1, right 1, because the radius is the same on a circle all around. So there's our circle. So there's our first question answered, which was to graph it. Second thing they wanted us to do is to solve for y. So they want us to get the y variable by itself. Okay, so to do that, I'm going to show you the algebra. All we're going to do is we're just going to subtract this chunk, this whole thing, on both sides. We're just going to subtract that whole chunk on both sides. So over here it cancels out. And we're left with y squared equals 1 minus x minus 4 squared. Then, to get the y by itself, we will square root both sides. Now, on the left side, this square root will cancel with that square. But on the right side, you don't want to forget. We're okay? Yeah. Okay. So, we're going to square root. So on the left side, the square root cancels the square. And on the right side, don't forget this. You get a plus and a minus. Which means we actually have two equations now, don't we? We have y equals a positive 1 minus x minus 4 squared. And we have y equals a negative 1 minus x minus 4 squared. Okay, so Diane asked a question. Her question was, why is this square root still there? Because I didn't actually do a square root over here. Now, some of you guys might be tempted to take the square root of 1 and get 1, right? And then have the square root also cancel this out. But that's breaking an algebra rule. This, the square root of a squared plus b squared, is not equal to a plus b. Hold on, my phone decided to start talking about me. So you can't do that. Something that you can do is this. If you had a squared times b squared, then you can do it. That would be ab. Just okay, but when it's plus or minus, you can't do that. So we can't actually simplify these square roots here. So we're going to leave them just like that. Now, let me ask you, this is a y equals, isn't it? So we're talking about what kind of halves here? Top and bottom halves or left and right halves? Good. And this one is a positive square root. So it's a what half? That's the top half of our circle. This equation represents the top half of my circle. This one is a negative, so that represents the bottom half of my circle. So what I've done here is by rewriting this equation, it's the same equation, but by rewriting with the y's by itself, we end up with two equations. And each equation represents a half of the circle. So we're going to come up here and we're going to label these now. So if you have a highlighter or a different colored pen, that might be helpful here. I'm going to label the top half here as the positive version of that equation that I just found. So y equals the square root of 1 minus x, was it minus 4 squared. And then I'm going to label the bottom half of my circle as the same thing, but it's the negative version of it. Yeah. So now that's the end of our question. That's part C. So part A was to graph the circle, part B was to solve for y, and part C was to label each half. Now, why do we do that? Well, first of all, here's one reason. One reason is I don't remember. There was one class I failed to mention this to, but did I tell you guys yesterday that conics are usually not functions? Yeah. Okay. So conics are not usually functions. And the reason why we talked about is because they fail the vertical line test, right? You don't need to draw that, but they fail the vertical line test, right? But if I think of the top as one equation and the bottom as a separate equation, now they're both functions, right? I've just broken up this equation into two functions. And that's beneficial because now anything that you can do with functions, you could do with a circle. You just have to do it in two separate equations. That's one reason. Another reason why is just because I've seen tons of problems in calculus. Like I said, I'm preparing you guys for calculus. Tons of problems in calculus where circles are written like this and they're much easier to work with in that format as opposed to this format. This format's cool because it's really easy to graph, but they're presented like this a lot in calculus. So that's why I like it. So that's the two reasons we're going over this. All right. So let's do another one. Kind of work on this one together here. So let's go ahead and take a look at part B. It's already printed for you once again. Okay. Your kids are like using holograms and stuff. You'll be confused too. On the printout, you guys, can you rewrite the equation? I changed it. Can you guys scribble out the one that I put for you and change it to this one, please? So let's do this. So besides the fact that the directions are telling you that this is an ellipse, you should be able to know that because both variables are being squared, so it's not a parabola. And also, the denominators are different, so it's not a circle. So that's an ellipse. So let's go ahead and do this. X minus 2 squared over 9 plus y minus 2 squared equals 1. Okay. Is that correct? Okay. So let's graph it. Center of my ellipse is 2, 2. What is the left and right radius? And what is the up and down radius? 1. Okay, so let's graph that. So I'm going to go left and right 3. 1, 2, 3. 1, 2, 3. Up and down 1. And that's part A. Just graphing, right? You take the square root of 9. Mm-hmm. All right. You guys ready for part B? I think on this one it told us to solve for x, right? Okay. So let's do that. I'm going to just rewrite the equation really quick.
Did you go down one?
Just up and down. Okay, so I want to solve for x. What would I do first, you guys? Okay, so I heard Armani say one thing. We could do that, and what I heard some other things. What was that? Move what over?
Oh yeah, move the y.
Minus 2. Yeah. So it doesn't really matter which one you do first. I'm going to go ahead and just kind of stick with the same steps I had last time of moving this chunk over first. But you did have the next step right. That will work. So move the chunk over that you don't want with the x. And now what Armani had said was we don't like that denominator, right? So what you do is you multiply everything by that denominator. So times 9 times 9 times 9. Those cancel, and you're left with this. 9 times 1 is 9. Now here we're not going to distribute this 9 because this is being squared, which means if you put the 9 in there, the 9 is going to get squared too, but it's not being squared, right? So we're not going to do that. We're just going to leave it out in front like this. Now what? Square root both sides. Now on the left side, these cancel, and on the right side, we get a plus and a minus, right? And And we have one more step to complete this process, which is what? Add the 2 over.
Are those 9s?
Yeah. And so now I've got my 2 halves of the circle, a plus and a minus, square root of 9 minus 9, y minus 2 squared plus 2. All right.
So 1 times 9 is 9.
So I'm going to ask you guys a question now. I have an x equals, which means we're talking about what type of halves here? Left and right. And the positive one is the right half of the circle, and the negative one is the left half, right? I don't know if you want to write that on your paper, but I don't want you to think of like an official math symbol or something. But so what I'm going to do then is I'm going to come back up here to the top now, and I'm going to label each half. Okay. So the left half of this circle is the negative one. And was it plus 1? Oh, 2. And the positive one is the right half. I'm going to use a different color though.
Is it plus 2 under the radical 2 or no?
No. We moved it after we had already taken the square root, so it is not under the square root. So we have time for maybe you guys to try one problem before we leave. So I've got a student practice here for you guys. If you want to try an easy one, the top one's a little bit easier. If you want to try a harder one, the bottom one's a little bit more. But they're both relatively the same, honestly. So go ahead and try one of those.